Okay, today I'm going to start chapter 3, that is numerical method. Okay, under this topic, there will be 3 subtopics, starting from solution of nonlinear equation, followed by Newton-Raphson method, and the last one, trapezoidal rule. So we will cover 3.1 and 3.2, both in lecture 1, whereas 3.3 in lecture 2. Moving on. Okay, numerical method. It can be used to find these 2 options here. Okay, meaning that to find the solution for the appropriate solution for nonlinear equation, examples of nonlinear equation is like this. If you are given an equation of 2 sine x minus x equals to 0. So this is a nonlinear equation. Okay, so for this type of question, we will use Newton-Raphson method. And then the second one is to find the approximate values for the definite integrals. Okay, examples of this. Okay, to tackle this, we will use trapezoidal rule. Okay, so 2 different approach for 2 different type of questions. Okay, if you are given a nonlinear, you use the Newton-Raphson method, and if you are given the definite integral form, then you use the trapezoidal rule. Okay, moving on. Okay, numerical method can be used to find an approximate root or solution. Okay, the keyword here is approximate. Okay, nilai yang paling hampir tepat dengan arti kata lain lah. Okay, for example 1, this quadratic equation can be factorized into x plus 1 and x minus 5, and you will end up having 2 exact root, that is at -1 and 5. So 2 exact root from this quadratic equation. So these are exact root. Okay, 2 exact root. Okay, or 2 different roots lah. Okay, as for example 2, you are given the equation of cubic and involving exponential term. How to factorize this? So most non-linear equations, so obviously this is non-linear equation. It has no exact root. So meaning that, can this question be solved? No, it can be solved. Okay, only that our final answer, the solution, will be in decimal form. So how to solve? Now the Newton-Raphson method comes in. Okay, by using Newton-Raphson method. Okay, moving on, 3.1, solution of nonlinear equation. How to find an initial approximation value or the first approximation. Okay, so the initial approximation value, meaning that the starting, we would like to test for what value. So it is represented as x0 or x1. So this is our initial approximation value, which I will short formally use it as IAV, initial approximation value. Most of the time, we will use x1. Sometimes it is also being used as x0. Okay, either one. Or the first approximation. Okay, this is our first initial approximation value, either x0 or x1. So there are 2 methods in finding this, either by using graphical or algebraic. This, if it's not being given in the question. If the question state already using the first initial approximation value of x equals to 1, for example, then you just use that given value. If it's not given, then you have these 2 options. One is by using graphical, second one is by using algebraic. Okay, so finding an initial approximation value or the first approximation using graphical method. So obviously, if it's graphical method, you need to sketch the graph. Okay, sketch the graph. And then the real root is the point of the intersection between the graph and the x-axis. Okay, so the point where the graph intersect the x-axis. Okay, so that's the initial approximation value that we will take. Okay, or okay, this one, the first one, this is if it's only involving one graph. Okay, if we happen to have one graph. Okay. If the second one, if we have two graphs, then okay, it's not to say that we have two graphs. We have one equation, but the equation is a complicated equation. Okay, you have one equation, you are given one equation. Okay, this is fx, which is a complicated equation. And then from one equation, you turn to two new equation. Okay, daripada satu fungsi yang complicated, boleh nak dilukis, jadikan dia bentuk dua fungsi yang berbeza. From one equation, you make it up to two equation, two simple equation. And then you sketch these two equations. So this is 1, 2. So you sketch both separately. So the point of intersection between these two graphs is the initial approximation value. Okay. So if you need to use your graphical method, and then if you have to use the algebraic method, then you need to find two values, that is A and B, okay, by substituting. Here means that by substituting x equals to A and x equals to B in our fx and indicate the result as two different signs. Okay, for example, you substitute x equals to A in your FA, you end up having a positive sign, and then you substitute x equals to B in your fx, you end up having negative signs. Okay, so this is what we want. Okay, this is what we want. Different sign in both. Okay, this one you end up having negative, positive. This one you end up having negative. Okay, so it has different sign. So what does this different signs mean? There's at least one root that lies between A and B. Okay, so your initial approximation value will be in between your x0 or x1 will be in between the A and B. Okay. Moving on to the first example. So this example will elaborate more regarding how to find our initial approximation value using our graph. Okay, look at the approximate value for the equation. This is what I mean by a complicated function. Okay, so you are given one complicated function. How can you find the intersection between this function and x-axis? It will be hard. That is why from this one complicated function, you rewrite, make it into two simpler function. Okay, so bring over x minus 2 to the other side. So you will end up having a new form of ln x equals to negative x plus 2. So ln x will be your first function to sketch. Negative x plus 2 will be your second function to sketch. So now sketch these two functions individually. Okay, this is our ln x, hx. The blue one, the green one is obviously a straight line of linear intersect at 2. Okay, intersect at 2. So our initial approximation value will be the point of intersection between these two graphs. This at this. Okay, so roughly the approximation value will be in between 1.1, 1.5 lah, meaning that any value is in between 1 to 2. This graph is not that accurate, okay? Okay. Or if it's to be more exact, you can choose as from graph 1.4 then. Okay? So you have to make sure your graph is accurate, then your initial approximation value will be the best options there. Okay, moving on. Example 2, by drawing a suitable graph find the initial approximation value of graphs or function of 7 cos x minus x equals to 0 from 0 to 2 pi, including, okay, so you make up to two different functions, bringing x to the right hand side. So you end up having 7 cos x equals to x. So 7 cos x as your first function and y equals to x as your second function. So now sketching both graphs. Okay, so our aim now is to find the intersection point between these two. So it will be there. Okay, the approximation value. Oh, there's two intersection point. Yes, another one more here. Okay, so how do we end up having this? Definitely by using calculators. Okay, when you equate both functions. Okay, solve for 7 cos x equals to x. Okay, you will end up having this. Okay, moving on to the next example. By drawing suitable graph, find the initial approximation value for the given function here. Okay, still both the given equation is a complicated function to be sketched. So make it up to two simple function. So what I will do here is to bring 1 to the left hand side and to bring negative 2ex to right hand side. So we will end up having, okay, so this as our first function and 2e negative x as our second function. So it will be a combination between quadratic and exponential. Okay, so our quadratic with a minimum value at -1. Okay, and then e to the power of negative x. Okay, so it's this way around. Okay, with the intersection at 2. So the point of intersection will be, okay, here lah. Okay, but this will be in between what to what? You don't have a point. Okay, so if we check at the exact value of this graph, when you substitute equals to 2, it will be 3. Then if 2 is here, definitely the point of intersection is between 1 to 2, which you will take 1.5. You can take 1.5. Okay, these are some of the examples of finding the initial approximation value, the x0 or x1 using your graphical method. Now we will move on by using algebraic method. Okay, show that the equation has a root that lies between x 0.2 and x 0.3. Okay, so the first thing, you need to let this function be fx. Okay, so let fx equals to the function given. And then now, you substitute this value of x. So, x at 0.2 and x at 0.3. Substituting x at 0.2, okay, into your fx and evaluate the answer, which you will end up having negative 0.96, which is obviously a negative value that indicates less than 0. And then you substitute for the value of at 0.3, evaluate by using your calculator, and you end up having a positive value of 0.756. So obviously this is positive. Okay, so this is what we want. This is how we need to end up having one negative, one positive. Okay, different sign. Okay, you have to end up having both giving you a different sign, one negative, one positive. Okay, since this is a show question, you have to write your conclusion. So how to write a perfect conclusion is by writing since, by starting with since f of 0.2, which has a negative value that is less than 0, and for f of 0.3, we end up having a positive value that is more than 0. Thus, okay, thus The equation, answer back the question. Okay, to show that the equation has a root between what and what, answer back the whole sentence. The equation of fx has a root that lies, okay, just copy back the answer, the sentences, between 0.2 and 0.3, a perfect conclusion. Okay, and not just the conclusion, the indicator that it is less than 0 and more than 0, which indicate it is negative and positive, also important, must be written. Okay, moving on to next question. Okay, can you see a simple elaboration here? This is what it means. So this is when x equals to 0.2, this is when x equals to 0.3. There's a root that lies between. Okay, when 0.2, you end up having a negative value. Here you end up having as a positive value. So obviously, what happens in between that? There's a root. Root means that intersection with x-axis. Okay, and your conclusion. Okay, another one more examples of algebraic. Okay, just to emphasize how important it is for you to indicate a positive and negative statement and your conclusion. Okay, to have a perfect conclusion. Okay, show that the equation has a root that lies between -3 to -2. So that indicate we have to substitute x equals to -3 and -2. Okay, starting off, you have to let your fx given function, and then you substitute x equals to -3 into your fx, evaluate, you'll end up having a negative value. Okay, negative value, and then you substitute for -2, you end up having as a positive value. So now make a conclusion. Okay, starting with stating that it has a different sign, that is one of negative and the other one of positive, and finally, copy down the questions to answer back the questions. Okay, the equation of x has a root that lies between. Okay, this indicates has a different sign. Okay, negative value, positive value, and your conclusion. That's the root lying between -3 and -2. Okay, understand.